In this film, we aim to demonstrate an efficient new device, Trishool, the triple-edge wedge tool, a three-directional nucleus cracking classical simple machine. The authors have no financial interest in the subject matter of this film.
Climbing the Rocky Mountain the way you want is not always easy, but breaking and moving them is an impossible dream.
There is an inspiring story of Indian mountain man Dashrath Majhi,
a poor landless laborer who moved a mountain so that his people could reach a doctor in time after his wife died due to its interference. He single-handedly cut through the 300 feet tall mountain just with a chisel and a hammer and carved out a 360 feet long and 30 feet wide road amid rocky terrain in northern India.
In his difficult task, chisel, the wedge tool, played an important role in cracking and breaking these solid hard rocks with higher level of safety and efficiency. This got us into thinking, if it is possible to move a mountain with such a simple tool and easy mechanical forces, why can't we use the similar tool to crack and break these rock-hard cataracts?
Wedges are one of the important classical simple machines that changes the direction and amplifies the magnitude of a force and help us the work done easier. Wedges have prismatic triangular shaped structure with a pointed apex and a broad base. It functions by converting a force applied to its blunt end into forces perpendicular to its inclined surfaces. Wedges, when pushed or driven into a solid hard substance, generate transversal fracture force and causes them to crack and split in tension. That is why wedges have been successfully used in rock excavation system since the ancient time. Cracking force is generated by chisel rack pick, a specially designed wedge tool. It has been ascertained that cracking and breaking is quite easier if the forces are applied at the open edge or naturally weak point on the surface of these hard rocks with a wedge tool having an angulation of 60 to 90 degree. Physically, these mature hard cataracts are almost identical to these solid hard rocks, very firm, compact and highly resistant to compressive forces, not easily sculpted, crushed or chopped, but at the same time they are weaker in the tensile strength, so easily crack and break with transversal fracture force. Current choppers have flat profile tip with minimal wedge angulation, either with sharp or blunt inner edge, designed either to facilitate cutting maneuvers in horizontal chop technique, where chopper cuts the nucleus in a centripetal direction from the periphery toward the center where the phaco tip is located, or used to penetrate the central hard nucleus in vertical chop technique. In order to incise, penetrate or pull apart the central hard nucleus, they exert greater shock or strain with high-intensity crushing compressive forces, which often results into incomplete nuclear segmentation and intact posterior plate, creating problems for the surgeon to complete the emulsification procedure.
The difficulty encountered in cracking and breaking these solid hard cataracts led us to design and devise a tool based on the principle of chiseled rack picks to crack and break these solid hard cataracts.
Based on the principle of classical simple machines and Griffith's theory of brittle fracture, an extensive scientific wet lab experiments were carried out. The results obtained by the experiments and method used by the tool designer, we developed Trishool, holding all the properties of chisel rack pick used in rock excavation system. The tip is incorporated with triangular wedge design, apex at the inner edge of the tip while wide and flat based at the posterior surface of the tip. Tips with several vertex angle of the wedge inner edge were tried. We found that the tip with 75-degree angled wedge generate maximum transversal fracture force with highest amount of force amplification.
Biggest challenge in the whole study was how to use the wedge inner edge of the Trishool, the wedge tool, within the capsular bag to crack and break these rock hard cataracts.
After intensive experiments, it was discovered that to generate optimum tensile force, the tip must be hooked around the open edge equator of the hard nucleus. It is the equator where mechanics of tensile fracture can be initiated in a more direct manner by simply driving the wedge inner edge of the tip through the equator of the nucleus. To provide counter resistance to the driving force of wedge tip through the equator, the phaco tip should be positioned firmly, holding the nucleus just within the equator.
So let us see how these choppers work in the hard cataract. So I'm going to use this.
To position and hook the device around the equator of the hard nucleus, we created a large central capsular axis with an intended 5.5 to 6 mm in diameter. Complete hydro procedure is performed and confirmed by rotating the nucleus that is totally free inside the capsular bag. To achieve firm grip at the equator of the nucleus, the phaco tip is engaged just distal to the center and impaled along the superficial plane, keeping the tip directed towards the equator using the hyperpulse or bus mode at high vacuum settings of 450 mm of mercury with 50% power. Once nucleus is firmly held with the phaco tip, it is then slightly drawn so that distal edge of the nucleus is brought just within the capsulotomy edge. Tip of the wedge tool is then very simply passed and hooked around the equator of nucleus under direct visualization, adjacent and parallel to the phaco probe.
Trishool is then
Swiftly drawn into the open edge equator of the nucleus against the counter resistance provided by the phaco probe. Once complete nuclear division is achieved, the nucleus is then rotated 90 degrees and same procedure is repeated to further break the nucleus into multiple fragments. Each free lens fragment is then drawn by the phaco probe and emulsified. While driving the apex of the wedge through the equator, the input force applied at the base of the wedge is converted into forces perpendicular to its inclined surfaces, creating a transversal fracture force, which overcomes tensile strength of the hard nucleus and initiates a full thickness crack at the equator, which automatically traverses through the center and to the equator on the other side, cracking the entire nucleus into two.
Trishool, the wedge tool,
is the simplest of tools, which enables us to crack and break the hardest of hard cataract with very little effort. Cracking the nucleus with the 75-degree angled wedge
Trishool,
hooked around the equator is the easiest of all technique, requiring extremely low forces and minimal manipulation. To conclude,
Trishool
helps us to create a full thickness nuclear crack so that nucleus can be very simply split into complete free segments. Complete nuclear segmentation achieved propagate a quick and safe nuclear fragment emulsification, ensuring less endothelial cell loss and less post-operative inflammation, leading to a faster recovery and maximal visual rehabilitation. Thank you for being with
Trishool,
the wedge tool, a modified classical simple machine to crack and break the hard nucleus.